Hello, good evening. What's up, Miss Wally? As you know, we're doing our geometry honors project about water displacement, and this is our figure. Nice little bouncy ball. Ages 3 to 9, maybe above, however you like to get down. Good for wall ball, but also good for a great classroom experiment about water displacement. So, to find the dimensions of it, we took a measuring tape and we measured out the radius to be 5, which would make the diameter 10. So then, since the diameter is about the same thing, the height, width, and length will still be 10, because it's yeah. So then, what we did next, we plugged it into the sphere formula. As you can tell, it's a sphere. For volume, from what we learned in class, whatever chapter that was, can't remember. So the formula is V equals 4 divided by 3 times pi times the radius cubed. So we plugged that in, and we ended up with 104.7. That's rounded to the nearest tenth. So now what we're going to do is we're going to put it through the process given on the sheet by placing it in the water and then trying to figure out if we get the same relative number and compare those two calculations. Sit back and enjoy.
Hi, Miss Whitley. The volume of this here beaker would be 400 milliliters. And to recap, the volume of this ball was 104.7. So if I plop the ball into the water, you get a measurement of 500 milliliters. If you subtract 400 from 500, that would be 100. And we got a volume of 104.7, which is pretty darn close to me.
So, to get back to the main part of this, here we have this ball. It's a nice little bouncy ball, multicolored. As my partner Curtis already said, this water is 400 millimeters in a clearly labeled container, as you can tell. So then, by placing the ball in here, what happens is the water will rise to 500 millimeters. And with the object in there, you can determine the volume of the object by finding the difference of the pre-plunge object and the post-plunge object in the water. So we're just going to take out the ball. Yeah, it's a little wet, so I'm probably just going to leave that in there actually and explain. So to begin, obviously 400 taken away from 500 would equal 100 millimeters to be the volume of this ball. And as my partner Chris said, it is really, really close to 104.7, which is our estimated volume. Yeah. So, I mean, it's pretty basic stuff. I mean, from what we learned, I think we were able to apply everything to get the result. So it is relatively similar, and it would be the same, because if you can, based off the size of the ball, like, it should not be, and that, like, the volume should not be that much higher based off the dimensions of it only having a 5 centimeter radius. So I think this test is actually really accurate based off the amount of water. And I think if we were to use any water of value, like start off at 300, we would still get the same with 400. So like I said, the ball in there brings up to the water level to 500 millimeters. And you know, subtract 400 from 500, you get 100. So I think this is a pretty legit project, and I think me and partner are both gonna have to go with yes, it is relatively similar.